Ho ho ho, my fellow introverts! Merry Christmas and a Happy New Year! I wish all of you to have loving, safe, and cozy Christmas holidays so that all of you return from them fully rejuvenated and very, very happy. So, I'm Stacy, your programming and test automation expert, and today we have a Christmassy episode where we're going to learn some more stuff about Python, including magic methods, of course, and we are going to implement a mini game. Well, it's not going to be a proper game, but it's going to be something like a guessing game mechanic or something like that. So, we will start in a moment, but as usual, before that, please don't forget to like the video, subscribe to our channel, and check the links in the description so that you don't miss anything important which can be linked with this video. So, I think we can get on with it. So, what is the idea of our game? You are a Christmas present, which have to find its Christmas tree. So basically, what you have to do, you have to provide how many steps you are going to do forward in order to find your Christmas tree. You don't know where the Christmas tree is situated, how many steps you have to do until you find it. So you are kind of guessing it. So we're going to have an input where we're going to ask our player how many steps he or she is going to take. And then we are going to basically generate where the Christmas tree is located. And we're going to run it. And our present is going to move the amount of steps which the player have provided. And if it matches, if he or she reaches the Christmas tree, then we're good. So we actually have found the tree. If not, well, game over. Basically, we have to try again. So, very simple game. To be honest, of course, there are multiple possibilities to make it even better, to add more mechanics. But you will see there is quite a lot of fun already with implementing this. So, I suggest we just start here. So, let's start implementing our cool mini game. First thing that we need to do is we actually have to ask the user how many steps they want to take towards our Christmas tree. So let's do that. So steps equals input. How many steps you want to take? Maybe do you want to take? Okay. Here we go. Probably we're going to have it as an integer, because we want to do some arithmetic operations on this later on. But yes, just let's keep it this way for now. So now we have our steps, and we have to somehow react to those steps, and we are going to have a class that is responsible for actually chasing the Christmas tree. So let's go ahead and implement the class. So I will call it Christmas Chase. Let's put an init here, and let's accept some steps here. So here we will just create an instance attribute called steps. Okay, so we can go ahead and create an object. So we are going to call it Chase. Chase equals Christmas Chase, and our steps are going to go here, right? Maybe let's just, to be very safe, let's call it input steps, and call it input steps here as well, so that we don't mess it up with these steps that are passed in here. Okay, so we have our object of the Christmas Chase. Now we have to actually define how we're going to chase it. And this is where I want to show you one probably an overkill here, but an interesting feature of magic methods. So basically, if you think of a chase, the chase can be a noun where you just say that this is a chase, but you can also do what? You can chase something, right? So our class, which represents a Christmas chase, can be actually a noun, but it can actually also be a verb, so that you can chase something, right? Basically, if we're talking about classes, usually they represent some objects that are created from them. So we usually represent a noun. But what if we could make a verb from a class? And it could serve both purposes. It could be a noun, but also a verb. So, how to do this? We're going to use a new magic method, which is called the call magic method. So, let's go ahead and define it. And I will just put a print here called. We're going to put a print with args and quarks here. Okay. So, we have our magic method. What does it give us? Let's try to run our code and see what happens. So we're being asked about the steps that we want to take. So let's put a 4 here, for example, and nothing happens. Everything works as it was before. So you can use the object of this class as a callable. So you have created kind of a callable. So you added some functionality to your class so that the instances that you are using can be callable. Which brings us the situation that we can do chase and put some parentheses here, and let's see what's going to happen. So for code, and here are our arguments and keyword arguments. So as you can see, having the call magic method defined here makes our instance callable. So we can kind of use it in our case, and here in this magic method, we can actually do the implementation of the actual walking. This is what we're going to do right now. One thing I wanted to do, because this annoys me quite a lot, we need to put a /n here so that we don't have to input it right away in the same line. We will have a new line here. Okay, so now let's go towards making some steps. This is going to be quite fun, I would say. But first of all, we need an avatar for our main player in the game. I told you that we're going to play as a Christmas gift, so this is why we need a Unicode sign to actually display a Christmas gift. So I have it stored, so let's just copy it into our script. So gift equals, and here is the Unicode sign. And we can actually do a print of this sign here. Print gift. Let's run it. Yeah, let's say 6. Okay, here you go. Nice looking Christmas gift. So, what we have to do, we have to actually be able to move this gift forward towards our Christmas tree. We're going to place the Christmas tree soon in our script, but first of all, let's try to move it forward. I would say that moving forward in the terminal is going to be adding some spaces before our Christmas gift. So therefore, we're going to have a for loop, which is going to add as many white space signs before our present icon as many steps we're going to take. So let's do it for step in range self steps, right? Because we want to move the amount of self steps. And now we want to actually print the gift, and we want to increase the amount of white spaces each time that we move forward. So let's put an F string here. Here is going to be our gift, right? Just like that. And we need to do something like this as well. So white space, step. Okay, let's see if it works. Let's try to run it, but probably we want to have some timer here. I mean, not timer, but some sleep here, because it's going to be too fast. It's just going to, walk right away. So let's do from time import sleep, and we're going to do a sleep right after each step. Let's do half a second. So let's take 7 steps. Okay, as you can see, this kind of works, but what is quite annoying is that you have multiple lines here. If this is a real game, which it isn't, but basically, if this is a game, we expect that our gift is moving in one line, right? How to do it in console? So basically, the simplest idea here is to actually clear the console each time that we are rendering our new gift, right? So we're just going to do a clear or Control L in Linux, the command that you can do to clear the console, or just the clear command. And it's going to refresh our console. It's going to be empty, and we can display our gift again, but with the new position. So, how to do it in Python? Basically, let's create a new method here. We're going to call it clear terminal. And basically, we are going to do the commands that we usually do in the terminal to be able to clear the console. So we need the OS library, import OS. And what we're going to do is we're going to do os system cos if os name equals nt else clear. So what does it actually mean? We're checking the operation system name. If it's NT, it means this is Windows, and in this case, we're using the COS command in the terminal. Otherwise, we're using clear. That's it. Anyway, it's going to just clear our terminal each time we call this method. So let's call it, basically. We need to call it inside our call magic method, inside of the loop. So we're going to do self clear terminal. So it's not going to work in the PyCharm built-in console. If we run it, you're going to see an error. So let me show you. You see, there is an error. So let me stop it. We're going to see these ones. We have to use the real terminal built into PyCharm, but you know, the one that is just the terminal. So we're going to use Python 3 call method random. Let's take 6 steps. And ta-da! Nice! Looks pretty nice. So as you have seen, our present have been moving 7 steps forward, and this is exactly what we need here. Okay, I think this is time to include our Christmas tree here. So on to our Christmas tree. Let's go ahead and create a class for it. I'm going to call it obstacle item, because we're not going to have only the Christmas tree, but we're going to have different obstacles which we meet while we're walking. And it's going to have an init. We will put some arcs here for now, and we will do self position equals, let's say, none for now, and we will have an Xmas 3 Unicode representation. Let me just copy it. Yeah, okay. We're going to print the arcs here just for debugging purposes. And now, what we want to do with this class. We could have, of course, generated the position here because we want to do it randomly. We want to randomly put the Christmas tree either further or closer to us. Of course, we're going to fill in the position in a moment, but how are we going to give this position to our Christmas chase? There is going to be an overkill solution right now, but I wanted to show you one more thing that you can do with the call magic method. So we are going to use the obstacle item as a decorator. Even so, it is a class, we can still use it as a decorator. Of course, if we do it this way, it wouldn't work because class or rather the instance of this class is not callable. We have to make it callable. The call magic method, I remind you, it actually makes something callable. So this is what we're going to do with our class. So let's do def call. Let's do a print called as decorator and print args quarks. Let's run it. First of all, as you can see before how many steps you want to take, we have something like this. Where is this coming from? If we go back, I think you already forgot about this, but we have the args passed into the init of the obstacle item, which is our decorator, and this is where it's coming from. So our Christmas chase is actually being passed into the args. This is the first thing you have to do. And now let's put a 1 here, the regular way. We've got some error, but we'll get back to it in a moment. But let's see, code as decorator 1 and an object, a dictionary. These guys were printed out, so we received the 1 here. This is the one that we have inputted here. Therefore, this one is our steps. So to revise it a little bit, if you use a class as a decorator and you have the call magic method defined, then first of all, the class instance goes here, right, to our args. And, basically the class goes to our args. Arguments of the init of this class are going to the call to here to args and quarks. Okay, one thing we're missing here, we actually have to create the instance of our class. So we need to do return. We need to, let's call it an instance. Instance, oh no. I spoiled it. Okay. Okay, and we are going to do self instance. Did we fix it? Let's check it out. I surely hope so. Okay. Works. This is how you make a decorator from a class. Now what we are left to do, we actually have to somehow add some logic to show our Christmas tree. So we have the obstacle class. We are defining the position here. So what we could actually do, just to make it a bit simpler, we could just return self here. What I'm trying to do here, basically, here, this is the creation of our Christmas chase instance. We're passing the args and keyword args of the Christmas chase, so basically the steps. But we can also inject something of our own. So we could have passed the self here as well. But of course, this way it wouldn't work because we only expect steps here. So we need another argument here. So let's call it obstacle, right? As I said, this is an overkill, but I wanted to show you how it looks like. Obstacle equals self, right? So to revise, we're creating the instance of Christmas chase here. We are giving it the args and quarks, which is our steps, and we're passing the obstacle as well, which is self. So basically the instance of this whole obstacle item class, right? So this is how we want to handle it. Now, when we have our Christmas chase class, we can do self obstacle equals obstacle. And this way, we're going to be able to access the position, the Christmas tree icon, or the Unicode representation, and anything else that we're going to define inside of this obstacle item. So we now have to actually generate the position. So let's do it here in this call magic method. So I have already imported the random library, and we can do self position equals rand int 1, let's say, or maybe 20. Let's do it 20. Okay, so our Christmas tree is going to be located from first position to 20th position, but randomly. We have no idea how far it's going to be located from us. Okay, so given that we have the obstacle defined here, we can reach the position doing obstacle dot position, right? Just like this. Of course, I'm not going to do this here, but this is how it's going to work. So now we have to somehow display the Christmas tree. First things first, we can do is actually to put the self obstacle Christmas tree here in, well, basically where we display the gift. And let's run it and see how it's going to look like, just to see the Christmas tree. So let's say free. And here we go. But as you can see, our Christmas tree is being also moved together with our present. This is not what we want to achieve, because we want actually the Christmas tree to be displayed further and the present to be moved further. There is going to be some kind of a distance that we have from us, the present, to the Christmas tree. And this distance is going to be less and less and less each time that we approach to the Christmas tree. So basically, the amount of the white spaces before our step is growing, but after our step is reducing. We just want some kind of a variable, which is going to be called distance left or something like this. And long story short, this is going to be our obstacle position, right? So the distance which is left when we start from 0 point is the actual position of the tree, right? And once we move further, the distance left is going to be decreased by 1, right? Each time we move forward. So we need to say that this is self obstacle positioned, right? So this is the whole distance from 0, which we're going to start from. Then we're going to have the white spaces being multiplied by the distance left. And one more thing that is left to do is actually to have the distance left being reduced by 1, minus equals 1. Something like that. Let's check it out. Let's say 4. Ta-da! It works. Of course, here, as you can see, we haven't reached the Christmas tree, so we actually lose the game. And if we have reached it, then we have to actually win the game. So what I propose to do is that we are going to have an if here, if distance left 0, right? We reached the tree, so we have 0 distance till it, so we were decreasing the distance by 1, and we just reached it. So if it's 0, then we just say print you have found the tree, right? And we can basically do a return here, because we want to stop the cycle. We just want to stop the game and basically say that you have won. So let's check it out. 5. No, we didn't reach it. So let's say 20, just to be safe. Okay. Let's see what's going to happen. Yay! You have found the tree, so we won. At the very end, we could actually say that the game is over. So we could do print, but of course outside of our loop, can say game over. You didn't find the tree. Okay. Let's try it out. Let's say 8. Game over, you didn't find the tree. Okay, this is about the Christmas tree. This looks quite fun already. So as you can see, we kind of move forward and we either find the tree or not. But now let's add other variants of the obstacles, and I will show you one last thing about call magic method. Let's extend our game, make it more risky, and instead of finding the Christmas tree, you might also find some fire or you might find a bear which is going to eat you. Okay, so what we need to do, we are going to actually extend our obstacle item. So we will have a bear, self bear, and let's copy the Unicode. Right, and we will have a fire. Okay. So now we have the bear and the fire, and we have to somehow randomly set whether we meet the Christmas tree, the bear, or the fire. So you will never know. And to do that, we again we're going to use the random library, but we're going to use another method of it. So let's actually add another instance attribute. So in self type equals none, and we're going to have self type equals random dot choice, and we are going to create a tuple here of our possible objects: self Christmas tree, self bear, and self fire. Okay. And we don't have to do anything else here because we're passing the whole object here, but we will have to add some logic which is going to say that if we've met the fire, then we actually die in fire. And if we have met a bear, then it has eaten us. So what I propose to do, we could have done it here right away, but I propose that we create another method, def get outcome, and here we will handle whether we've met fire, whether we've met a bear, or if we have met the Christmas tree, then everything is fine. If self obstacle type equals self obstacle bear, print you were eaten by a bear. Okay. Elif self obstacle type equals self obstacle fire, print you were caught on fire. And last but not least, else, and we can just copy what we have written here. Okay. If it's not a bear and it's not a fire, then it's a Christmas tree. So we actually win in this case. So here, where we had our if distance left, we were winning previously, but here we can do self get outcome. And this way we're going to react whether it's a bear, a fire, or a Christmas tree. Okay, as simple as that. One more thing I wanted to show you guys, instead of just putting everything into the call magic method, we could just do get obstacle, or maybe fill obstacle object. And we could do call just like that without any functions equals fill obstacle object, just like that, and it will work the same way. Whatever you like, you can use it this way. So let's run it and test our luck. Okay, 17. It's a Christmas tree. Oh my, we have some issue. 1 second, let's see. Why were we caught on fire? Let me think. What did I do wrong? Aha, okay, yeah. So instead of hard coding the Christmas tree here, we have to actually use the type here. This is one thing that I forgot to do. We're setting the type here, and we don't have to show the Christmas tree here, but we have to show the actual picked item. So let's test it out again. Yeah. Okay, 17. You have found the tree. Okay, so let's do 8. 3 again. Come on. Random. Yay! Let's see. Are we going to burn? Yes, we burned. Did we... Will we get the bear? Yes, we will get the bear. Okay, so here we go, guys. This is basically it. This is what I wanted to show you. So let's jump into the conclusions. I hope you liked the whole adventure. Okay, guys. So this was it, our Christmas adventure. I really hope you liked it. If you want to play the game, then you will find the link in the description. If you want to make another version of this game, just go ahead. You can just download the code from the link and you can extend it and actually send link in the comment or just reach out by email and send the version. I'm really interested what you are going to do with it. So this is it. This is what we have learned today. The call magic method, some random operations, and how to clear the console. Maybe not much, but I hope we had fun. So guys, I wish you happy Christmas holidays again. I wish you a very happy coding, and I will see you in 1 week.